Are there more grains of sand in a sandbox or more stars in our galaxy? The answer is more surprising than many people expect. Take about 5 minutes and try to find out for yourself. Today's challenge is about estimation, orders of magnitude, and clever approximation. The key is to develop a sensible strategy for your estimate. Read the problem carefully and first try to solve it on your own. Then compare your solution with my step-by-step explanation. The result may surprise you. But what is even more interesting is how just a few simple ideas can produce a remarkably good estimate. Great to have you back. Today, we are looking at an exciting estimation problem. It is about the contents of a sandbox. The sandbox has an area of 4 square meters and is filled with sand to a height of 30 centimeters. 1 grain of sand has a diameter of 0.1 millimeters. We need to find A, the number of grains of sand in the sandbox, and B, a comparison with the number of stars in our galaxy. Our Milky Way contains approximately 100 billion stars. Before we start solving the problem, we look at the significant figures. For an estimate, an accuracy of 1 significant figure is sufficient. An estimate is often considered acceptable if it is accurate within a factor of 10. That means accurate within 1 order of magnitude. It is also important that, when estimating, you should not use a calculator. However, you may use a pen and paper. By the way, this type of estimation became well known through Enrico Fermi, and problems of this kind are also called Fermi problems. Now let's begin. Step 1, we determine the volume of the sandbox. Volume is area times height. So 4 square meters times 0.3 meters. This gives 1.2 cubic meters. For an estimate, we round this to 1 significant figure, so approximately 1 cubic meter. Step 2. Now we look at a single grain of sand. A grain of sand is approximately spherical. The diameter is 0.1 millimeters. The radius is half of that, so 0.05 millimeters. Now we convert this into meters. Milli is a prefix and corresponds to 10 to the power of minus 3, so we replace the prefix milli with this value. 0.05 is 5 hundredths. That means 5 times 10 to the power of minus 2. We combine the exponents and obtain the radius, 5 times 10 to the power of minus 5 meters. Step 3. Now we calculate the volume of 1 grain of sand. For a sphere, the formula is 4/3 times pi times radius cubed. We substitute the value. For pi, we write 3. This can be canceled with the 3 in the denominator. We obtain 500 times 10 to the power of minus 15. Since we only need 1 significant figure, we replace 500 by 5 times 10 to the power of 2. The result is approximately 5 times 10 to the power of minus 13 cubic meters. Step 4. Now we determine the number of grains of sand. We divide the total volume by the volume of 1 grain of sand. So 1 cubic meter divided by 5 times 10 to the power of minus 13. This gives approximately 2 times 10 to the power of 12 grains of sand. Step 5. Now we compare this with the stars. Our galaxy has about 1 times 10 to the power of 11 stars. We form the ratio. Grains of sand divided by stars. This gives approximately 20. Conclusion. In the sandbox, there are about 20 times more grains of sand than stars in our Milky Way. This shows, even here on Earth, there are incredibly large numbers. Well done. You have solved a typical estimation problem. Very important, there are situations in which essential data is missing, and an exact calculation is either impossible or collecting the data would take too much effort. In these cases, an estimate is helpful, although it is not scientifically precise. Sometimes you can also make a rough calculation to get a feeling for the order of magnitude. Just give it a try and have fun until next time.